Did you know the average American home can spend over $1,500 a year on electricity and yet remain completely at the mercy of power outages, grid failures, and rising rates? Most homeowners don't realize that the lights turning on in their home every day depends on a massive, fragile network far beyond their control. But what if there was a way to store and access energy in your own home, reliably and on demand, without waiting for the grid? Today, we'll explore the hidden systems that could make this possible. Electricity is the invisible backbone of modern life. From heating and cooling to refrigeration, lighting, and electronics, our homes run on power that we often take for granted. But dependence on the grid comes with hidden costs and vulnerabilities, blackouts, inefficiency, and limited control over when and how energy is used. In this video, we'll look closely at a surprising approach to home energy that challenges conventional assumptions. You'll learn how energy can be stored differently, how everyday systems may be costing more than we think, and what structural insights reveal about the future of residential energy management. By the end, you'll understand not just the problem, but the possibilities for solutions many homeowners never consider. Section 1. The hidden costs and vulnerabilities of the grid. The typical home is connected to a sprawling network of power plants, transmission lines, and substations. When any part of this system fails, electricity stops flowing. Outages can last minutes or even days, leaving homeowners scrambling. Beyond reliability, cost is a significant concern. Electricity rates spike during peak usage, and many homeowners pay hundreds more than they need due to timing and inefficiencies. Most people never see the full picture of what they're paying for, or the vulnerabilities that come with reliance on the grid. How could a household regain control over its energy supply? Section 2. Conventional alternatives and their limitations. Many turn to generators, solar panels, or battery storage for backup. Generators are fuel-dependent, require maintenance, and can be noisy or bulky. Solar panels are weather-dependent, expensive, and often insufficient alone. Batteries store electricity but degrade over time and have limits on capacity and discharge rates. Even with these systems, homeowners often face gaps in availability and performance. The misconception is that installing a backup system solves the problem completely. But in practice, limitations remain. Section 3. Beyond batteries. Mechanical energy storage. Energy can exist in many forms: electrical, chemical, thermal, and mechanical. One overlooked method is mechanical storage, storing energy through motion. For example, a spinning flywheel can store kinetic energy and release it as electricity when needed. Historically, this technology was industrial, but recent advancements have made it practical for home use. The result is a system that can deliver power instantly, independently of sunlight, fuel deliveries, or grid availability. How does this translate into everyday home energy use, and what are the challenges in scaling it down for residential spaces? Section 4. Technical and practical challenges. Integrating mechanical storage isn't as simple as dropping a flywheel in your basement. Consider friction, durability, noise, and the efficiency of energy conversion. Many homeowners assume that if something works in a lab, it will work at home. But scaling introduces complications. The mental barrier is significant too. Most people have never thought about energy storage in terms of spinning machinery. Yet, when designed properly, these systems can provide reliable, immediate energy with minimal long-term maintenance. What would it take to make such a system practical for everyday use? Section 5. Understanding energy flow in the home. Most homeowners only see electricity at the end point: lights, fridge, heating. But energy flow within a home is complex. A mechanical storage system introduces additional dynamics. Energy is stored kinetically, converted on demand, and then distributed through household circuits. Understanding this flow is critical. Even with stored energy, bottlenecks or inefficiencies can prevent full utilization. Many people overestimate how much energy their backup systems can actually provide. Section 6. Awareness and preparedness. Energy independence is not just about cost, it's about awareness. Most households never ask, what happens if the grid fails tomorrow? Considering alternative storage methods, including mechanical systems, shifts the mindset from reactive to proactive. Curiosity becomes a tool for preparedness. By understanding the underlying principles, homeowners can identify gaps, evaluate options, and make informed decisions that go beyond simple backup solutions. Section 7. Practical steps for home energy management. To approach home energy strategically, there are 4 steps. 1. Identify gaps in current energy supply. 2. Assess peak energy needs. 3. Explore alternative storage beyond solar and batteries. 4. Evaluate space, cost, and maintenance considerations. Even without installing a system, applying this framework helps households think critically about energy use, efficiency, and independence. In summary, the challenges of home energy are layered: cost, reliability, independence, and hidden limitations of conventional solutions. Mechanical energy storage highlights an often overlooked opportunity to manage energy structurally and intelligently. Understanding energy flow, storage, and conversion allows homeowners to anticipate problems and consider solutions with a clearer perspective. Even minimal awareness changes how we approach energy in daily life, offering a framework for resilience and control. Imagine a home where lights never go out, appliances run uninterrupted, and energy is stored invisibly, ready on demand. How would this change your daily routine, your energy costs, and your sense of security? What would be the first appliance you'd power if the grid went down? Comment below. I'm curious to see your thoughts. Follow for more insights on home energy systems, storage principles, and innovative ways to think about energy independence.